Something strange is happening at the edge of our solar system. Distant icy worlds are drifting in ways that defy explanation. Astronomers believe the answer might be a hidden giant, an unseen planet 9 lurking far beyond Neptune. New surveys are picking up bizarre motions that fit the predictions, but the mystery is far from solved. Could we finally be on the verge of finding a new world, or will the search reveal something even stranger? Keep watching this video to know more about this topic. The debate over Planet 9 began in earnest a decade ago, when researchers noticed unusual alignments in the orbits of certain Kuiper Belt objects. The simplest explanation seemed to be the gravitational pull of an unseen planet. Simulations suggested a world 5 to 7 times Earth's mass, orbiting so far out that it would take up to 20,000 years to circle the Sun once. The case has grown more intriguing with recent studies. Astronomers tracking the motions of distant icy bodies found subtle anomalies, small accelerations, and deviations from expected paths. These shifts could not be explained by Neptune, random collisions, or galactic tides. Yet, when an additional, unseen planet was added to the models, the anomalies suddenly fit. For Konstantin Batygin, one of the leading proponents of the theory, this was a striking confirmation that the hypothesis deserved serious attention. Another promising lead came from re-examining infrared surveys taken decades apart. A faint moving object was spotted in both IRIS 1983 and Akari 2006-2011 data. Some suggested it could be it, but there was a problem. Its orbital tilt seemed far steeper than expected. While intriguing, the mismatch meant it could not be identified with confidence. Adding to the complexity, discoveries in the outer solar system have not always supported the Planet 9 picture. The Subaru telescope found a distant dwarf planet, nicknamed Ammonite, with an elongated, stable orbit. Rather than strengthening the clustering argument, Ammonite seemed to weaken it, suggesting the outer solar system may be shaped by forces other than a single giant planet. Another newly identified object, 2017 OF 201, also followed an orbit that doesn't fit neatly within Planet 9's predictions. The possibility of a ninth planet is not just a curiosity. It touches on the fundamentals of planetary science. If such a world exists, it could be the solar system's missing super-Earth, a type of planet common around other stars, but absent here. Confirming it would align our system more closely with the patterns seen elsewhere in the galaxy. Supporters of the theory emphasize that the clustering of orbits is too consistent to be random. The recently observed orbital anomalies add another layer of evidence, suggesting a gravitational influence that has yet to be identified. For these researchers, it offers the simplest explanation. Skeptics argue differently. They note that observational bias could be creating the illusion of alignment. Telescopes are more likely to detect objects in certain regions, and that skew could make the orbits appear clustered when they are not. If so, Planet 9 might be an unnecessary addition. Alternative theories also exist. Patrick Likauka, a Japanese astronomer, has proposed that the hidden world might not be a super-Earth, but rather a smaller body, 1.5 to 3 times Earth's mass, on a highly inclined orbit. This Kuiper Belt planet could account for some of the anomalies without requiring an object as large or distant as Batygin and Brown suggest. Still more speculative is the idea that Planet 9 could be a primordial black hole. Such an object would be no larger than a grapefruit, yet hold several Earth masses. Though almost impossible to detect directly, it would exert the same gravitational pull as a planet. While highly speculative, it illustrates how far researchers are willing to think outside the box to explain the evidence. The hunt for Planet 9 is now at a turning point. Current telescopes can only probe so far, but the next generation will soon provide a clearer picture. Chief among them is the Vera Rubin Observatory in Chile, expected to begin wide-field sky surveys soon. With its ability to capture vast swaths of the night sky at high sensitivity, Rubin could either detect Planet 9 directly or rule out much of the space where it is thought to reside. If Rubin succeeds, the discovery would be historic. A new super-Earth in our solar system would confirm that we are not so different from other planetary systems, and would provide a unique laboratory for studying such worlds up close. It would also validate years of simulations and offer astronomers a chance to investigate its composition, atmosphere, and potential moons. But if Rubin finds nothing, the implications will be equally important. A null result would mean the anomalies must be explained another way, through smaller bodies, observational biases, or as yet unaccounted for gravitational effects. Such an outcome would not diminish the importance of the search. Instead, it would force astronomers to refine their models and perhaps uncover new aspects of orbital dynamics. Beyond Rubin, other approaches are being explored. Some researchers are investigating whether a black hole could reveal itself indirectly through gravitational lensing or faint signals from dark matter interactions. Others are cataloging more distant trans-Neptunian objects, looking for additional evidence of clustering or unexpected orbital paths. The discoveries of Ammonite and 2017 OF201 show that the outer solar system is far more varied than once thought. Whether or not they point to it, they highlight just how little we know about this region. Each new detection expands the map and sharpens our understanding. Planet 9 remains a mystery. Hints of a hidden world clash with theories of black holes, smaller planets, or flaws in our models. The next decade with the Vera Rubin Observatory could finally bring answers. Until then, the hunt continues. Will we discover a new world or rewrite the rules of planetary science? Stay tuned.